Okay, let's go ahead and figure out this math word problem. Now, let me go ahead and read you the problem. You can see it in the title of this video, but effectively what we have is an airplane flying at 10,000 feet and it's descending at a 30-degree angle. And we want to know how far does this airplane have to travel to land? Okay, now of course we need to kind of simplify this, but effectively this is kind of a visual representation of the problem, right? So an airplane descending means it's going down, its nose is pointing down and it's descending at a 30-degree angle. So it's going to have to go and follow this path to land here at the airport. So I don't want to give you too many hints here because I want to let you have an opportunity to figure this thing out. So if you think you can get the right answer, go ahead and put that into the comment section. I'm actually going to show you the correct answer in just 1 second. And then we're going to be talking about all the various little details of this problem that you need to be aware of. I will give you a little bit of a hint. We are dealing with angles, so we're going to have to use a little bit of trigonometry, which is the study of angles to solve this problem. So if you've never studied trigonometry before, don't worry about it. It's going to be pretty basic stuff, but this is a pretty typical trigonometry or algebra or geometry problem. If you are taking geometry, just know that there is algebra in geometry, and even algebra problems, still have kind of basic geometric type of problems like this. Okay, it all ties in together. But anyways, I'm going to go ahead and show you the correct answer in just 1 second. But before we get going, let me quickly introduce myself. My name is John. I'm the founder of TC Math Academy. I'm also a middle and high school math teacher. I've been teaching math for decades. I absolutely love teaching mathematics. And I can tell you right now, all of you can be successful in math. And I'm especially speaking to those of you that struggle in math, or maybe you're having a difficult time with your current level of math. Maybe you were doing great at math and now you're in like algebra 2, and now this class is hard and you're having a tough time. Listen, it doesn't make a difference if you failed math or now you're struggling in math. All of you could be successful in math. Does it require a lot of work to be successful in math? The answer is yes. Yeah, you do have to study. You got to put effort in. Okay, that's kind of common sense. But beyond that, what you need is great math instruction, right? You need to be learning from someone or something that you understand that instruction. And not only do you understand it, it's comprehensive. It really explains everything in detail. So, if you need help in your current math course or maybe some sort of special test that you're getting ready for, something like the SAT, ACT, ASVAB, GED, GRE, GMAT, teacher certification exam, all those exams and many, many more have a dedicated math section on it. Or if you're homeschooling mathematics, check out my math help program. I'm going to leave a link to it in the description of this video. I literally have over 100 plus different math courses that span these categories and much, much more. I'm also going to leave links to my math notes in the description as well, because a lot of you out there are not taking awesome math notes. Okay, you're taking maybe okay math notes. Some of you aren't even taking notes at all. You need to make your notes as perfect as possible because that work, right, and the focus to get your notes to be awesome will help you learn math. Okay, so improve your notes and everything else will get much, much better. But in the meantime, you can use my notes if you like. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so let's go ahead and take a look at the answer to this question. How far does this airplane descending at a 30-degree angle that is currently at 10,000 feet, how far does it have to go to land? I.e., we're looking for this location right there. So that distance is 20,000 feet. Okay, so hopefully you got this correct, but if you didn't get this right and you were working on the problem and you got confused, well, listen, don't run away. This is not that difficult. And this is a pretty typical type of high school level math problem, right? You're going to see this angle of descent, angle of ascent, things like this. But let's just go back up here and make sure you understand, right? So this airplane, if it was flying straight and level, it would be parallel to the ground. Okay, well, it's kind of like here, that's a little bit better. So this airplane would be parallel to the ground, but it's descending at 30 degrees, meaning that this angle right here is 30 degrees. So if you were confused about that, that's what an angle of descent means. But how far does the airplane have to go to land? What distance are we talking about? We're not talking about this distance. The airplane's actually going to be covering this distance here. So this is the distance we're looking for. And you can see here, it looks like we're going to be forming some sort of triangle. And if you're thinking triangle in terms of how to solve this problem, well, you're thinking correctly. All right, so let's go back and celebrate your success. For those of you that did get 20,000 feet, that's pretty awesome. Matter of fact, let me give you a nice little happy face and A plus, a 100%, and multiple stars to celebrate your awesomeness in math today. Nice job. Okay, so let's get into the solution to this problem. So, what you want to do in any math word problem, okay, is to try to model the situation. Now, sometimes you can do it visually. Some problems you can't do it, but any way you slice it, you want to try to model, what's going on. So, take the problem, read it multiple times, understand what's going on, and then try to figure out an approach to kind of visualize the information in the problem. So obviously here we're going to deal with some sort of triangle. So let's start off by just drawing a triangle. And we know that this triangle, okay, this right here will represent the altitude, right? That's pretty straightforward. We got this distance and this distance here. Okay, so this part right here, this angle of descent, this is probably the part that confuses a lot of students. So again, here, if the airplane was flying just parallel to the ground, it's just kind of like flying along with the ground, doing its thing. But if it wants to land, it's got to start descending. So this angle of descent here would be 30, or it's 30 degrees in this particular problem, but it represents this 30 degrees right here. Well, the triangle that we're concerned about is this, okay? So we want the angles here and here, and we know that this angle, by the way, is a right angle because altitude, the airplane, all right, when it's flying directly above the sky, we have the altitude, it's going to be perpendicular to the ground. So we have a 90-degree angle right there, but we're interested in these angles right here, and all we have is this angle right here, this angle of descent. Well, if you think about it, if the airplane is flying straight and level, okay, this also right there would have been a right angle, okay? So that would make sense, it's because you're kind of forming a rectangle. So if you didn't see that if this line, if you kind of extend this line out here, for those of you that are in geometry, what we have is two parallel lines. This line here and this line here are parallel, and this would be effectively like a transversal. So this 30 degrees and this 30 degrees would be what would be called what we describe as alternate interior angles. Okay, basically they are going to be the same. So this angle of descent here is going to be this angle right there. But just in case you didn't know that, you could easily say, okay, well this is 30 degrees. I know this angle right here would be and have to be another 60 degrees to form a right angle, right? Because 30 and 60 is 90. So this is 90, or this right here would be a total of 90 degrees. But we have 60 degrees plus this 30 degrees, which is 90, plus this other 90 right here is a total of 180 degrees. But the bottom line is this, however you thought about it, okay, let me just kind of erase all this stuff right here. You need to understand, okay, and the only way you're going to understand this is to actually do these type of problems, okay, these angle of descent and ascent problems, which is pretty common in geometry and algebra 2 or basic trigonometry. You need to be able to form a triangle and have all the correct information in this triangle, all right? So anyways, this is probably the part of the problem that confused some of you. But anyways, if you now are like, oh, okay, I get it. We're dealing with a triangle that's a right triangle here and 30 degrees here. So let's go ahead and now take a look at kind of a more simplified version of what's going on. All right, so here's our triangle. We have 10,000 feet, which of course represents the altitude of the aircraft. It's descending at 30 degrees, which means this angle is 30 degrees. So what is the distance this airplane is going to travel? Well, the airplane's not going to be on the ground, okay? It's not covering this distance. It's actually going to be flying this distance here. And that might be confusing to some of you, but this is what the problem is asking, right? This is the actual path the airplane will be flying, okay? So we want to know what is the distance to land? So, we don't want to kind of simplify this. You kind of, some of these word problems, you kind of have to make them simpler. Don't be like, well, what if the airplane was, having to kind of fly in the middle of the airport, on the runway, da da da. These problems are designed to be nice and simple. So don't overthink the situation. Okay. So we're looking for this distance or this leg of this length of this triangle. All right, so we have a right triangle, we have 30 degrees, and we know this side. Well, what we need now is some basic trigonometry, and we can figure this out. Okay, so basically the problem is this. We have a right triangle, 30 degrees here. Of course, we know this angle is 60 degrees. We know this side is 10,000 feet. We're looking for x. We're looking for this side here. So what you want to be doing is thinking of basic right triangle trigonometry. Okay, and you want to be thinking about what we call trigonometric ratios, those lovely buttons that are on your calculator: sine, cosine, and tangent. All right, sine, cosine, and tangent. Now, this is trigonometry. It's basic right angle trigonometry, and typically this is kind of introduced at the geometry level. Okay, it's kind of a little light introduction to trigonometry. But like a full trigonometry course, like my full trigonometry course would be part of my pre-calculus course, but I also teach basic right angle trigonometry in my geometry course as well. So in geometry, you should start being familiar with trigonometric ratios, sine, cosine, and tangent, and how to solve these type of problems. So again, you can see this type of problem in a geometry course, maybe an algebra 2 pre-calculus course for sure. All right, so when you kind of recognize this as a basic right triangle trigonometry problem, you need to always remember this little phrase right here, SOHCAHTOA. All right, SOHCAHTOA. And what does that mean? Well, it means that the sine is equal to the opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So what are we talking about here? Let's go ahead and show you. So here is a triangle, okay, the one that we're going to actually be using. Here's the angle, okay? So we're talking about a trigonometric ratio. A ratio is basically comparing two different numbers, i.e. a fraction. So looking at any right triangle, the longest side of that right triangle is always going to be the hypotenuse, and we'll call that h. So you can see here we have O, H, and A. Now, the angle or the side that is next to the angle that we're looking at. Okay, we're looking at this angle. The side that is like connected to it or next to it or adjacent to it, that's what that A stands for, adjacent, is A. And then what is the side that's opposite of that angle? That we would call that O, all right? So H, A, and O when we're looking at any particular angle. Okay, this is going to be how we're going to define these trigonometric ratios. So the sine of 30 degrees, the sine is the opposite over the hypotenuse, which would be this length over this length. Okay, we can write it that way. The cosine would be equal to the adjacent over the hypotenuse, okay, A over H. Of course, if we had this information, we can calculate all this stuff out. And the tangent of 30 degrees would be equal to the opposite over the adjacent. So when you're solving a problem like this, you need to kind of assess what information do I have and which trigonometric function do I select. Okay, well, let's just think about it here. So we have this angle. What information do we have? Well, we have this right here. Okay, we have this piece of information. Now, with respect to 30 degrees, what is this? Is this O, A, or H? Well, this is going to be the opposite. Okay, we have the opposite. And what are we looking for? Well, we're looking for this side right here. We're looking for the H. Okay, so we have the opposite. We're looking for H, so we're going to want to find, select a trigonometric function that involves O and H. And which one involves O and H? Well, you can see here it is the sine. Okay, it involves O and H, and that's how you select the correct trigonometric ratio to solve your problem. Okay, so we're going to need the sine to figure this thing out. And now that we know which trigonometric function, we now got to put this thing to work. All right. So what we're going to do is say the sine of 30 degrees is equal to the opposite over the adjacent, or is opposite over the hypotenuse, so this over this. So the opposite over the hypotenuse, we know that the opposite is 10,000. Okay, we actually have that number, but we don't know what this h is, so we'll use a variable like x. Okay, so this is now what this distills down to. So the sine of 30 degrees is equal to 10,000 over x, and you can just think of this as a simple proportion, like this sine of 30 degrees over 1. Okay, you can always have anything over 1. And now you have a nice, lovely proportion where we can use the cross product to simply cross multiply. And if you're confused about that, let me just show you real quick. A proportion is two equal fractions. So 1/2 is equal to 3 over 6. You can always cross multiply. 6 times 1, or 1 times 6, is equal to 2 times 3. You can see both are equal. 6 is equal to 6. That's why this is a proportion. You can always use the cross product to solve. So we're going to take x and multiply it by sine of 30 degrees. Now, in a moment here, you want to grab your calculator and figure this out. Don't do this yet, okay? And we'll talk a little bit more about sine of 30 degrees in just 1 second. But we're going to have x times sine of 30 degrees and then 1 times 10,000, okay? So we're going to use that cross product to set up for this basic equation, x times sine of 30 degrees equal to 10,000. How do we solve for x? Easy, just divide both sides of the equation by sine of 30 degrees, okay? Yeah, I didn't write that in there, but you can see that work. So we have to figure out 10,000 divided by sine of 30 degrees. Make sure your calculator is in degree mode. And when you do this work, just go into your calculator, 10,000 divided by sine 30 degrees, hit enter, you get 20,000. So a lot of you are saying, well, that's a nice, integer value, whole number value. Wow, that's interesting. You would probably think that this is going to be some sort of decimal. Well, sine of 30 degrees happens to be equal to 1/2. And as you get into trigonometry, you're going to really need to know the sine, cosine, and tangent of some what we call very common angles. Things like 30 degrees, 60 degrees, 45 degrees, 90 degrees, etc. So technically, you didn't really need your calculator to solve this problem, but a lot of you, probably would have forgotten, oh yeah, that sine of 30 degrees is 1/2. No big deal. Your calculator is going to give you the right answer. It's going to be 0.5. But anyways, when you do this calculation, you get 20,000. And of course, that represents feet, okay? Because this unit of measure here, that 10,000 is in feet. And when you give your final answer, make sure you give that correct unit of measure. That is important, okay? 20,000 feet. Just don't put down 20,000, okay? Because some math teachers who are kind of, a little bit mean, they may be like, hey, you know what? You didn't give me the feet, so I'm going to give you 9 out of 10 points, okay? Just to kind of make sure you never forget that. Listen, that is a reality, especially in science and classes as well. Things like physics and chemistry. Don't forget units of measure, okay? That is important, all right? So always put down your units of measure, and any problem that you're dealing with when you have units of measure in that problem, miles, minutes, seconds, feet, it doesn't make a difference. You need to be kind of on extra alert in terms of working whatever units of measure you're working with, and what is the question asking here. Here, I'm just saying, how far is it to land? I didn't tell you how many miles, how many meters, none of that stuff. So you can give this answer in feet, and that's perfectly fine. Okay, so again, if you need this, if you need help with anything related to this problem, that means that you're probably in a geometry course, maybe Algebra 2. It all depends on your particular math class. It could be college algebra, intermediate algebra, or maybe you're in college taking Math 101 that has some basic trigonometry. Whatever the case is, if you need to know real deal, like full-on trigonometry, you want to check out my pre-calculus course. If you're interested in more basic right-angled trigonometry, of course, I teach that in my pre-calculus course as well. But I do teach that in my geometry course, right, because of the introduction to trigonometry. But whatever the case is, don't walk away from this problem, especially if you're in a math class, and be like, yeah, I hope I just don't see this again. Like, I don't get this, and maybe if I just hope, I just cross my fingers that I'll never come across a problem like this again. Well, I'm telling you right now, these angle of ascents and descent problems are pretty common. So figure this stuff out. You definitely can do it. But with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.